Hello class, welcome to the next segment in the week 13 material, and in this segment we're going to take a look at a couple of NumPy functions that can make our calculation process a lot easier when we're working with large multidimensional data sets like you're going to be working with for this assignment. And the first such function that we'll look at is the mean function, and the next segment we'll take a look at the max and min function. But first, just to sort of get our bearings straight, we'll take a look at the mean function first, just to sort of see how this all works. So up here I have the same two-dimensional list that we had defined up in week 9 when we first two-dimensional array. I want to make sure I am precise with my language, but this is the same exact two-dimensional array that we had back in week 9. So you may remember that from a long time ago. And then down here I have a command that looks something like 2dim.mean0. So this right here is this variable right here does in fact point to our variable that we have defined up here, which is holding on to a two-dimensional array. Now, what exactly is going on with the dot mean 0 here? Well, let's find out. So just like before, I'm going to go ahead and express this two-dimensional array as sort of a matrix or something that is two-dimensional. And what this dot mean 0 actually does is the mean takes the mean. So that hopefully should be sort of self-explanatory. This is in fact going to take an average of numbers. Now this 0 right here, that's when things get a little bit interesting. This right here, this 0, tells the computer that we want to take the average across the 0th dimension. So remember, this is a two-dimensional array, so there's really two different ways I could take the average or the mean. I could take the mean across all of the rows, which is what the 0 does, or I could take the mean across all the columns. And if I wanted to take a mean across all the columns, we'll take a look at that example of that later, but instead of the 0, I would have the 1 here if I wanted an average across all of the columns. So dot mean 0 means I want to take an average across all of the rows. So what that amounts to is we're going to take each individual row, add them together, and then divide by the total, since that's the definition of the mean. So this will do the calculation of 5 plus 11 plus 22, which should be 38, and then divide by the total, which is 3, so it'll do 38 divided by 3. Then combining these, the other numbers in the other rows together, we get 8 plus 13 plus 25, which would be 46. Divide that by 3 to get a number. And then here I get 6 plus 16 plus 22, which should be 48, and divide that by the total to get a result for that. And so here, this would be the end result of applying dot mean 0. So remember that our sort of nomenclature for arrays, the first value that you put in the brackets corresponds to a row number, and the second value corresponds to a column number. So this kind of relates back to that. When we remember, the computer starts counting at 0, so dot mean 0 means we want the average across the 0th dimension, which is the average across all the rows. If we wanted dot mean 1, that would give us the average across all the columns. And one thing that's very important to notice with this operation is notice how I lose a dimension by using the dot mean operator. So I started with something two-dimensional, applied the dot mean, and I end up with something one-dimensional in the very end. So if you apply the dot mean function or the max or min functions, which we'll see later on, you're going to lose a dimension. So if you apply this to a three-dimensional array, you'll get the mean to a three-dimensional array, you'll get a two-dimensional array back. And if you apply the dot mean to a two-dimensional array, you're going to get a one-dimensional array back. So that's just something really important to keep in mind. Now let's go ahead and take a look at applying dot mean 1 to our array. So notice that's different up here. Now we have dot mean 1, which means we want to take an average across all of the columns. And if you want to, as an exercise, go ahead and pause the video and try to figure out what exactly the computer is going to print out by taking dot mean 1 of our two-dimensional array that we have represented on the screen here. So if you want to take a stab at it, which I would recommend, go ahead and pause the video and see if you can figure out what the result of this operation is going to be. All right, so if you attempted it, let's see if you got the correct answer. So again, dot mean 1, since we're taking an average across all the columns, this time we're in fact combining the 5, 8, and 6, adding those together to get 19, dividing that number by 3. Then we add the 11, 13, and 16 together to get 40, dividing that result by the total, which is 3. And then we add the 22 to the 25 to the 26, and get a result of 73, and then dividing that result by the total. And this should be the end result that you get when you perform that operation. Again, .me1 also gives me back a one-dimensional array. I reduce the dimensionality of the array by 1. So I started with a two-dimensional array. .me1 still gives me a one-dimensional array. And another sort of a side topic that, side note that might be useful, you can have just todim.mean without anything in the parentheses, but if you don't put anything in the parentheses, the computer is going to, by default, put a 0 in there for you, so it's just going to assume that you want the average across the 0th dimension. So usually it's a good idea to put the number in here that you want to take the average across, just to make sure the computer is, you and the computer are on the same page, which, as you've probably figured out by now, it is usually pretty important that is the case. So now I want to go ahead and relate this back to the data set that we were working with. So in this, so here we have our three-dimensional array called the underscore data up here. And here, if I wanted an average, keep in mind that the very first dimension, or the 0th dimension, is in fact the time dimension. So if I wanted an average across every single time entry in our data set, then I could do the underscore data dot mean 0, and that would give me a time average across the data set. So an average across all the months that I've specified. So in this case, since I have all 24 months still in the data set, that would take the average across all 24 months and give me back a two-dimensional array. Remember, the mean function reduces the dimensionality by 1. Since I started with a three-dimensional array, applying the dot mean will give me back a two-dimensional array. So time average, this variable on the left-hand side, will in fact have a two-dimensional array stored in it. And if I want to take an average across all of the latitudes, then I simply change the number in the dot mean function to 1. That will take the average across dimension number 1, which we saw is the latitude dimension. And then finally, if I want an average across all the longitudes, which is actually pretty common in something called a Hofmöller diagram, where you look at how something evolves with respect to latitude and time, and you take an average across the longitude to get that. But to accomplish that with our data set, we just simply put a 2 in the parentheses to say we want the average taken across dimension number 2, which is in fact the longitude dimension. So just sort of tie back what we just learned to the data set that we're going to be working with. Just a couple takeaway messages to sort of wrap up here. One is make sure you put a number in here, and also by applying the mean function to an array, you're going to reduce the dimensionality. So in the very first example we looked at, we reduced a two-dimensional array to a one-dimensional array. In this case that I have shown on the screen here, we're reducing a three-dimensional array to a two-dimensional array. So I think that's going to do it for the mean function. In the next segment, we'll take a look at the max and min function, which sort of behave the same way, as sort of the same idea, there's just the operations a little bit different. So with that, I will see you in the next segment.